Dear students, in this video we are going to derive the slope deflection equation. The slope deflection equation is used to analyze the indeterminate beams. The equation is very simple, but uh, during the process of derivation we can understand many concepts. For that, first we have to assume an element of beam subjected to a moment MAB and MBA. So I am going to assume the rotation takes place like this. Originally, MAB will be in this direction, simultaneously MBA. So the direction indicates the rotational of the element MAB and MBA. I put this line in inclined manner because I am going to consider the sinking of the support also. For example, you consider a continuous beam. We can assume or it can occur that the support B will sink at an amount of delta. In that case, we have to consider the delta. Otherwise, we can assume this diagram in a pure horizontal plane. In order to account of this deflection delta, I have drawn like this. So with respect to horizontal, I am going to draw a line. I am indicating this is psi, the angle due to this deflection. This is also psi. And the rotation. This rotation, I am going to draw another diagram. Our rotation is like this. With respect to horizontal, it is psi. Here also psi. The rotation here I am mentioning as theta A dash. Here theta B dash. Combining theta A dash and psi, the rotation is, that is overall rotation. The overall rotation is theta A. Here the overall rotation is theta B. So that we can write an relation theta A dash plus psi equal to theta A. At B end, theta B dash plus psi equal to theta B. So this is an initial relation from this rotational diagram. Okay. And we are considering the deflection at any one of the support, that is sinking of the support. The psi can be written as delta by L because the span of the element is L, the vertical, that is opposite by adjacent. Delta by L is psi. That is also an angle. Psi is also an angle. Okay. Keeping this, I am going to write theta A dash equal to theta A minus psi. Theta B dash equal to theta B minus psi. Theta A means overall rotation at A, theta B overall rotation at B. Theta A dash is the rotation due to the inclination. Theta B dash is the rotation due to the inclination at B. Okay. Now, this is the first step to indicate all the terminologies and the relations. The second step, apply a moment MAB at A. MAB at A. Okay. in the given direction. So the given direction is like this. So I am going to apply a moment in this direction. Definitely this element will be reflecting like this. So the opposite end will have the moment direction like this due to the hogging moment. Due to this hogging moment, we can get this directions. This is MAB. Here it is MB. I can mention theta A1 dash and theta B1 dash due to the applied moment MAB. And also, I'm going to draw the tangent of this rotation moment so that we will have the deflection values. We will have the deflection values. This is theta A1 dash equal to del of B towards A. This is del of A towards B. That is deflection at A towards B, deflection at B towards A. We can mention like this. Theta B1 dash is the rotation here. We can write theta A1 dash. Theta A1 dash equal to delta B by A and theta B1 dash equal to delta A by B divided by L because theta equal to opposite by adjacent. The adjacent length is L. Theta B1 dash equal to delta A by B by L. Theta A1 dash equal to delta B by A by L. B by A by L. Now, our responsibility is to find the deflection delta B by A and delta A by B. So this is only due to the application of MAB at A. Some moment will be creating at B. So our considered direction is followed only at A. So I am considering this is positive, but the resultant moment is not in the same direction of the assumed direction. So it is minus. The sign convention is first we have applied the moment in the same direction of taken the parameter taken into consideration, but our resultant moment at B is not the same direction as this. So we are putting negative to that point. So the next step is to find the deflection. Okay. How we are going to find the deflection? We are going to use moment area method. The second part we only consider MAB. We only consider MAB. So I'm going to mark the centroid distance L by 3. From B it is 2/3 of L by 3. Okay. From A it is L by 3. From B it is 2/3 of L by 3. Now the deflection equation equal to delta A by B or B by A, whatever may be, that is summation of area of BMD into centroidal distance. Into centroidal distance. So that the deflection from A to B, from A towards B, that is delta A by B. So by writing the area of triangle, half B is total length, height is the moment MAB into, from A it is L by 3, from A it is L by 3 into 1 by EA. So the basic equation having EI. Area of BMD into centroidal distance divided by EI. So MAB L square by 6EI is delta A by B. Similarly, delta B by A from the B support towards this direction, half into L into MAB into 2L by 3, because from B the centroid distance is 2 by 3 of L into 1 by EA. So it is MAB L square by 3EA. Okay. So our previous relation, theta A1 dash equal to del B towards A divided by L, theta B1 dash equal to delta A towards B by L. We are going to apply theta A1 dash equal to del B by A divided by L, MAB L square by 3EI into 1 by L. So it will be MAB L by 3EI. Okay. Next one, theta B1 dash equal to delta A by B by L, but it is in negative direction. Already I have told the rotation is like this. The only direction MAB is followed as our assumed terminology. MBA is not in this direction, it is opposite direction. So here we have considered positive, at the other end we consider negative. So minus del A, del of A towards B by L. Here minus MAB L square by 6EI into 1 by L. So finally get minus MAB by 6EA. So this is second part. We have finished the second part. The third part, we are going to apply a moment at support B or at the point B, and what are the effect towards A we are going to do. Consider our assumed direction is previously we have assumed the direction of moment is like this. So I am going to apply this type of moment. That is, this is the moment direction to get a sagging curve. So A is creating a moment like this. Here it is MBA. We have applied same type of moment at B. For that we have receiving the rotational direction at A like this. And this too is not similar, because this direction is towards anti-clockwise. This created rotation is towards clockwise. So consider positive at B end and negative at A end. Okay, and also the deflection. So previously at A del A by B, at B del B by. Okay, and now to find the deflection, consider the moment at B. You consider the moment at B, that is MBA, and the centroid is L by 3 from B and 2/3 of L from A. Okay, 2/3 of L from A. So now delta A by B, summation of area of BMD area into centroid divided by A. Okay. So the centroid from B it is L by 3, from A it is 2 by 3 of L. So now I am going to write the area of BMD similar to the previous one, half into B is the span L and the moment is MBA. We are writing delta A to B. Delta A to B. So the centroidal distance is 2/3 of L divided by EI. Okay. MBA L square by 3EI, because 2 get cancelled. So finally we get delta A by. So next one, delta B towards A. is half B and H is MBA into the distance from B towards A, the controller distance from B is it is L third. So L by 3 divided by EI. We got MBA L square by 6EI. And now the sign convention, which one is negative? From A to B, we have to consider it is negative. Okay. Next one, the theta A2 dash, because we are naming in this case theta A2 dash, here it is theta B2 dash. So theta A2 dash equal to what is theta? Opposite by adjacent. That is delta B by A divided by L. Theta B2 dash equal to, so consider this triangle B2 dash, the opposite in this delta A towards B divided by this span. So delta A towards B divided by span. So from the available value, B by A is this divided by L MBA L by 6EI, and this one we put minus for this, and MBA L by 3A. So we got four answers: theta A2 dash, B2 dash, and theta A1 dash and theta B1 dash. By superimposing this diagram, because we are applying a moment, we are applying a moment of MAB and getting all the values at A and B. And next one, we are applying a moment MBA and we got the results at A and B. By superimposing this, we can get both the moment applied at the simultaneous moment, that is MAB, MBA, which is first we assumed. So it is a method of superposition. So in this we got theta A1 dash and theta B1 dash. In this part we got theta A2 dash and theta B2 dash. To get the final combined effect, this rotation will be theta A dash, which is equal to theta A1 dash plus theta A2 dash. Here it is theta B dash, which is equal to theta B1 dash plus theta B2 dash. So we are just superimposing the two effects to get the combined effect. Okay. Now we are going to add theta A1 dash and A2 dash. First one, theta A1 dash equal to MAB L by 3EI. Theta A2 dash equal to MBA L by 6EA minus. Next one, theta B1 dash equal to minus MAB L by 6EI. Theta B2 dash equal to MBA L by 3A. Theta A dash equal to theta A1 dash plus theta A2 dash. Summing up, MAB L by 3EI plus MBA L by 6EI. Actually, this is minus, okay? Okay, minus. This one is minus. Next one, theta B dash equal to B1 dash plus theta B2 dash, which is equal to minus MAB L by 6EI plus MBA L by 3EI. And next we are going to equate theta A dash plus psi equal to theta A, because we have seen from horizontal it is psi, here it is theta A dash. The overall rotation is theta A, so theta A equal to theta A dash plus psi, and theta A dash equal to theta A minus psi. So we can equate this equation to theta a minus psi. Similarly, we can equate this equation to theta b minus psi. So we have to keep this equation as 1 and 2. We have to solve for the unknowns. What are the unknowns here? M A B L by 3 EI minus M B A L by 6 EI. This is equation number 1. Theta B minus psi equal to minus M A B L by 6 EI plus M B A L by 3 EI. We can eliminate any one of the moment to get the measurement. First, we are going to eliminate MAB. We can consider MAB to be eliminated. For that, if you multiply this equation 2 by 2, you will get 2 theta b minus 2 psi equal to minus 2 by 6 MAB L by 6 EI plus 2 MBA L by 3 EM. Okay. And the first equation I directly taken. First equation is theta A minus psi equal to MAB by 3 EI into L minus MBA into L by 6 E. So if you consider, we will get 3. The same terms can be eliminated. 2 theta b plus theta a minus 3 psi equal to, you can take MBA L by EI as common. MBA L by EI as common. You will get 2/3 minus 1 by 6. 2/3 minus 1 by 6. What is 2/3 minus 1 by 6? You take common as 6. So multiples of 2. 2 into 2 minus 1. So it is 3 by 6 finally 1 by 2. So you will get final equation as 2 theta b plus theta a minus 3 psi equal to 1 by 2 EI MBA into L. So this equation is theta a plus 2 theta b minus 3 psi equal to MBA into L by 2I. So our final equation MBA equal to 2EI by L theta A plus 2 theta B minus 3 psi. Okay, this is equation number 3. And I'm going to substitute in equation number 1 to get MAB. Theta A minus psi equal to MAB L by 3 EI minus MBA L by 6 EI. So I'm going to substitute MBA value in this place. So theta A minus psi equal to MAB L by 3 EI minus L by 6 EI into 2 EI by L 2 theta A plus 2 theta B minus 3 psi. So cancel the common terms. We will get like this. Okay. Theta A minus psi equal to MAB L by 3 EI minus 1 by 3 2 theta A plus, actually this is theta A only, not 2 theta A, this is theta A only. Theta A plus 2 theta B. So theta A plus 2 theta b minus 3 psi. So I'm going to multiply 1 by 3 inside minus theta a by 3 plus, sorry, minus 2 by 3 theta b plus 3 psi. Okay. Theta a minus. Keeping this term on one side by 3 ei into length. Bring all the other items on other side. Theta a minus psi plus theta a by 3 plus 2 by 3 theta b minus 3 psi. So I'm going to take 3 as a common denominator. So 3 theta a minus 3 psi plus theta a plus 2 theta b minus 3 psi. On left side, MAB L by 3 EI. Cancel 3 and 3. So finally, you add theta A 4 times 4 theta A, theta B 2 times theta B minus 6 psi, which is equal to MAB into M. Next, if you take 2 outside, 2 theta A plus theta B minus 3 psi equal to MAB into M. So MAB equal to divided by EI, here also divided by EI. MAB equal to 2 EI by L, 2 theta A plus theta B minus 3 psi. So this is equation number 4. Compare equation 3 and 4. These are the slope deflection equations. MBA, if you write the same term 2EI by L, and you have to multiply 2 with B and 1 with A. That is theta A plus 2 theta B minus 3 psi. For MAB, you multiply 2 with A and 1 with B. That is 2 theta A plus theta B minus 3 psi. So these are the slope deflection equations which we are going to consider in our problem.